This chapter provides an overview of the process and the multidimensional framework that will apply for the remainder of the course. Please note that some of the dimensions and considerations may not be applicable to your context. We will do a high-level overview of key terms relevant for our course. Let's get started. The term sewage is used interchangeably with domestic sewage, domestic wastewater, municipal wastewater, etc. Before the 20th century, sewage was usually discharged into a body of water such as a stream, river, lake, bay, or ocean. There was no treatment, so the breakdown of the human waste was left to the ecosystem. Now, the word sewage tends to refer to liquids or waste matter usually carried off by sewers. Today, the word sewage is slowly being replaced by the word wastewater. This means any water that has been affected by human use or touched by a human. The words sewage and wastewater are similar in the way that in the end we produce waste that is to be carried out by any means of transportation. The transportation includes sinks, tubs, showers, dishwashers, washing machines, toilets, and pipes, etc. Wastewater is used water. It includes substances such as human waste, food scraps, oils, soaps, and other chemicals. In homes, this includes water from sinks, showers, bathtubs, toilets, washing machines, and dishwashers. Businesses and industries also contribute their share of used water that must be cleaned. Although some people assume that the rain that runs down the street during a storm is fairly clean, it is not. Harmful substances that wash off roads, parking lots, rooftops can harm our rivers and lakes. There is also remarkably nutrient-rich opportunities that exist in wastewater, which is not often captured. To give you a sense of scale, the U.S. Environmental Protection Agency estimates that an American generates anywhere from 50 to 70 gallons of wastewater per day. We Americans generate far more wastewater than any other parts of the world. As the name implies, gray water is on the continuum between clear and clean water and black water with respect to treatment. This includes the leftover, untreated water generated from washing machines, bathtubs, and bathrooms and sinks. Gray water accounts for approximately 65% of wastewater produced in households with flush toilets. In a sanitation context, black water denotes wastewater from toilets which contain pathogens. Black water can contain feces, urine, water, and toilet paper from flush toilets. Another important term for our course is fecal sludge. This is the mixture of solids and liquids containing mostly excreta and water in combination with toilet paper, sand, grit, metals, trash, and other various chemical compounds. A distinction can be made between fecal sludge and wastewater sludge. Fecal sludge comes from decentralized systems like on-site sanitation technologies such as septic tanks. This fecal sludge has not been transported through a sewer. It can be raw or partially treated, digested, or a slurry or a semi-solid. This results from the collection and storage and treatment of excreta or black water with or without gray water, depending on the household system. Fecal sludge that is not managed safely and properly can have dire impacts on families, communities, and on society more widely. Although it's not the focus of our course, it's worth mentioning stormwater since it can be combined with wastewater. Stormwater is excessive rainfall that does not soak into the ground, but instead flows over the land's hard surface into the nearest water body through storm drain channels. Stormwater can be a problem because it carries considerable pollution along with it wherever it flows. EPA found that more than 1 in 5 households in the U.S. depend on individual septic systems or decentralized systems to treat their wastewater. These systems are used to treat and distribute relatively small volumes of wastewater, usually from houses and businesses located in suburban and rural locations not served by a public, centralized sewer system. The design and size of a septic system can vary widely. From within your neighborhood, there can be considerable variation to across the country due to a combination of factors. These factors include household size, soil type, site slope, lot size, proximity to sensitive water bodies, weather conditions, or even local regulations. There are 3 types of sewer systems: sanitary sewer, stormwater sewer, and the third one is a combined sewer system. For this course, we'll focus on sanitary sewers. In American colloquial English, sewer system is applied more frequently to the large infrastructure of sewers. The main purpose of a sanitary sewer is to carry waste from homes and businesses to wastewater treatment plants. According to High Tide Technologies, these systems are designed to handle human waste and easily degradable manufactured solids such as toilet paper and tissues. These underground systems consist of many miles of tunnels, piping, manholes, and pumping stations to transport the waste from houses and commercial buildings, but not stormwater, through the system. How these sanitary sewage systems work is by carrying human waste through small plumbing pipes in the home to gradually bigger pipes outside until it reaches the main sewer line in the street. From here, the sewage is transported to a wastewater treatment plant to be treated and returned safely to the environment. There are many types of sanitary sewer systems as well. This includes conventional gravity sewers, force mains, affluent sewer, pressure sewer, and simplified sewers. The goal of this course is to understand the process of encouraging households with septic systems to connect to a sanitary sewer system. While this course focuses on the process, technical expertise and an extensive understanding of local conditions will be critical in determining the best type of sewer or combined sewer system needed by the community. This course is about household connections. To define a sewer system connection, we will use a modified World Bank definition of a sewer system connection from 2017 with common legal definitions from Law Insider based in the United States. A sewer connection means the point where an individual sanitary service line attaches to the city's or the community's sewer system. This enables the discharge of an individual sewage waste stream to the sewer collection main. It includes the collection and conveyance of black and/or gray water from a household or property, and the exclusion of rainwater or surface water in the connection to the sanitary sewer system network. As we're learning during this chapter, sanitation is much more than simply sewers and toilets. Planners and engineers play an important role during all segments of the sanitation chain. The sanitation chain shows the importance of actions and stakeholders, each with its own particular challenges. The first stage in the sanitation service chain is the interface and containment. This is where black water or excreta is captured and stored. For some households, this will include gray water. Homes capture this excreta at the point of defecation to ensure it does not go untreated into the environment. The next segment of the chain is to empty and transport the fecal sludge or black water. For decentralized septic systems, this may be dominated entirely by private sector operators. The frequency of emptying and conveyance is tied to the availability and cost of service providers. Finally, communities have local laws to enforce treatment and disposal. Now to move to the crux of our course. Here is a visual depiction of the framework we will use to walk through the process of connecting households. Again, these steps and dimensions will vary by local context, laws, and existing practices and infrastructure. While the dimensions and points for consideration are not exhaustive, we will discuss many of them during this course. They will provide you with a high-level and systematic approach for making informed decisions. There are 4 key phases or stages we'll cover during this course. First, the assessment phase of the proposed program and infrastructure. Second, the planning and design phase of the new sewer system. Third, the implementation phase. And finally, the 4th phase, the monitoring and evaluation for the post-construction phase. These steps provide a high-level process for communities seeking to increase household connections. The designated entity overseeing the connection program needs to look at the process from the financial view, the institutional and legal angles, the technical position, and finally, the social lens of the intervention. Some communities may want to adapt the institutional and legal angles to include policies and regulatory perspectives. In the next chapter, we'll take a closer look at the first phase, the assessment phase, where communities look at their existing infrastructure and programs to determine the best path forward for the proposed infrastructure.